So what's next? Usually I like to start with any changes to my database first and then work from there, just because everything kind of flows from the data. And so again, let's stop and think for a second about what we're building. Our goal is to let any user create a post showing off their coding setup, their workstation, their battle station, whatever you want to call it, and then other users can rate them. And so to do that, we'll definitely need to add at least 2 additional tables, one for posts and one for ratings. And so even though we've already initialized our database, I'm going to head into the schema here and I'm going to update this a little bit. I think I'm going to actually get rid of the username, not because it's best practice, but because I want to show what happens. I want to show some issues with not having something like a username available. And then I'm also going to create 2 new tables here. So I'm going to create a posts table, which is going to have an ID that is a, let's just copy this and I'm just going to change this stuff here. So it should have an ID. We're also going to have a caption, which is going to be text. Actually, let's make it like a tweet. Varchar 140 characters. So varchar is just characters. How many characters? Exactly 140. That's the max we're allowing in this column. And then image URL. So this is going to be a URL of the actual battle station itself. And then we also want to save the user ID. Who is the user that actually is saving this post or is creating this post? And then let's create a, let's use that created at timestamp right there. And then let's also make sure that there's an updated at timestamp. Just in case we want to update this field, we want to also have that updated at available to us. Now this user ID here is referencing this users table, and so we're going to need to create a foreign key constraint on that. So we'll say foreign key, user ID, which references the users table and the ID column. And then if the user deletes, if we delete that user from the user database, cascade those deletes over to the posts table. We also want to create one here called ratings. And we're going to need a few things here. So I'm going to say rating, which is an integer, not null. And let's also check to make sure that the rating is greater than 0 and that the rating is less than or equal to 10. So we'll limit ratings to values or numbers between 1 and 10. We also want to have a post ID because users will be rating posts. And then we also want to have a user ID because we want to have the user who saved or who created the rating. And then we want to have this created at timestamp the same way here. Now notice we don't have a primary key for this table. And that's interesting. So we're going to do something cool here, but I'm just going to write some code and then we're going to talk about it in a second. I'm going to create a composite primary key. And you know what? I'm actually going to set my foreign keys here. Just straight in the column definition. And that is all we need for the moment. Now, there's a lot of stuff here. So let's stop. Let's take a quick pause for a second and just kind of have an overview of what's happening here. Now, these 2 new tables initially look like fantastically more complex, but in reality, they're just mostly the same, save for the way we're handling primary and foreign keys. Now, if you're not familiar with primary keys, these IDs here that say serial primary key, they're just used to uniquely identify each row or record in the table. And for posts here, we have an ID column as the primary key, along with the 140 character caption, the image URL, the user ID, which will represent which user actually created this post, and some timestamps. We're also, again, we're defining this foreign key at the bottom here, which is just ensuring that, hey, whatever we put in this user ID column, that has to exist in the ID column of the users table. We call that referential integrity. It just means that those 2 columns are related, and it ensures that whatever we put here has to exist in this column. There's really not much more to that is worth going through right now, but it's good to know exactly what those terms are. Now, again, this on-delete cascade thing here, it just specifies that when a referenced row is deleted, all rows referencing it should automatically be deleted as well. So if a user who posted their setup deletes their account, we'll tell Postgres to cascade that deletion action to this row also. There's other options you could set here like set null and restrict, but we don't need to worry about them. If you want to refer to the Postgres docs for more info on constraints, it's probably a good idea. But again, this is just something you'll see pretty often, so it's good to have it here. Now, this ratings table, we have more interesting things going on. We have a post ID that references the posts table, the ID column of the post table, and we have a user ID that references the ID column of the users table. So having two foreign keys in one table is what's known as a many-to-many model. Relationship, or many-to-many relationship, and it's different than what we've seen before. So we're going to talk a little bit about how we handle that. But for the time being, at least just notice that it is there are two foreign keys represented here. And notice we didn't explicitly say foreign key here. We just created that foreign key constraint directly on the column definition. That's totally fine. It's a valid way to do it. It just saves some space, to be honest. Now, the most important thing here, again, is that this primary key we created here is a composite of the post ID and the user ID. Now, why did we do that? The primary reason is that primary keys have to be unique. And so we're guaranteeing that the combination of these two things represent a unique value in the ratings table, which means that a user ID, can't create more than one rating for a single post. That is primarily why we do this, because leaving multiple reviews from one user would cause Postgres to throw an error. And that's exactly what we want. We want some of that to be handled on the database side of things to manage data integrity. Now, with that set up, oops, did I just type that? Yeah, get rid of that. Now, with that set up, all we need to do here is run our file again. So we'll say psql-f rate my setup.sql, and we will recreate it. Uh-oh, did I mess something up? Let's see what I messed up. I said user. It should be users, and this should be posts. Cool. Let's try that again. Yep. Error out. Let's do it again. Great. Great. Looks like all went well. That's what we want. Okay, cool. So database set up. We're ready to roll. Let's do our git dance. Git status. Okay, cool. Git add. Git commit. Database. Schema setup. And we're ready for the next section where we'll handle routes and models and all that goodness.